Welcome to the DIY Honda Garage channel. DTC U128D specifically indicates an issue where the automatic lighting control unit has lost communication with the gauge control module. This problem could lead to inaccurate readings on the vehicle's dashboard, particularly affecting tools like the tachometer that rely on the gauge control module for data. The communication loss could be attributed to various electrical issues, such as poor connections, blown fuses, or wiring problems. Understanding the components involved is crucial for diagnosing and resolving this DTC. The automatic lighting control unit is responsible for managing the vehicle's lighting based on environmental conditions. The gauge control module, on the other hand, relays information about the vehicle's speed, RPM, and fuel level to the driver. Effective diagnosis will require an extensive understanding of these systems along with systematic troubleshooting steps. The automatic lighting control unit is a critical component located in the vehicle that automatically adjusts lighting based on the vehicle's operational environment. This unit communicates vital information, including ambient light levels, to the gauge control module. The gauge control module, also known as the tachometer control, is typically found within the dashboard area, closely linked to the speedometer and other critical gauges. This module serves the important function of interpreting data from various sensors to present accurate information to the driver. A disruption in communication between these two components can lead to misreading critical data, like vehicle speed or engine speed, which are vital for safe driving. Understanding the locations and functions of these components is essential for effective troubleshooting. Identifying the root cause of the DTC U128D involves examining several potential issues. Firstly, loose or poor connections could disrupt the communication line between the automatic lighting control unit and the gauge control module. This is a common issue and can usually be quickly resolved by securing the affected connections. Additionally, the diagnostic step involves checking the blown fuse A29, located in the underhood fuse relay box. If this fuse has blown, it signifies an electrical fault within that circuit. Lastly, open wires or high resistance in either the B-CAN lines or the power and ground circuits could be responsible for the failure. Thoroughly examining these areas will help in diagnosing the specific issue responsible for the DTC. Drivers may notice several symptoms associated with DTC U128D. One prominent indication is the appearance of warning lights on the dashboard. These lights may illuminate to alert the driver of the system malfunction. In addition to warnings, there may be grappling with inaccurate readings on the gauges, such as the tachometer displaying incorrect data or failing to display at all. This can compromise a driver's ability to assess their vehicle's speed and performance accurately. Lastly, intermittent lighting failures can occur due to the loss of communication, contributing to unsafe driving conditions in low-light environments. Being aware of these symptoms is important for timely repairs and ensuring vehicle safety. The initial step in troubleshooting DTC U128D involves working with the Honda Diagnostics System, HDS, to clear any existing diagnostic trouble codes. Users should start by turning the ignition switch to the lock position and then back to the on position. This action resets the vehicle's systems and prepares them for a fresh diagnostic check. After performing this, it's crucial to wait at least 6 seconds to allow all electronic components to successfully initiate. Next, check for any remaining DTCs with the HDS tool to see if U128D has reappeared. If the code does reappear, it indicates that the issue persists, leading to further diagnostic steps. Conversely, if the DTC does not reappear, it may indicate an intermittent failure or transient fault, suggesting that the system is functioning correctly at that moment. Although checking for loose or poor connections would still be advisable, In the second troubleshooting step, the focus shifts toward verifying the gauge control module's connectivity and status. Access the Body Electrical System menu on the HDS and select B-CAN Control Units information. This section provides detailed insights about the communication lines between various control units, including the automatic lighting control unit. It's important to check the detect and not available information on the gauge control module. If the gauge control module is detected, it confirms that there is a connection, and you should proceed to step 7 in the troubleshooting process. However, if the module does not register as detected, it suggests a deeper connectivity issue that needs further investigation, prompting a transition to step 3. Moving on to step 3, checking the electrical fuse for functionality is an essential task. Specifically, you'll be inspecting fuse number A29, which is a 10A fuse located in the underhood fuse/relay box. This fuse protects crucial circuits, including those connecting to the gauge control module and the automatic lighting control unit. If the fuse appears intact and operational, you can proceed to the next step. Conversely, if the fuse is blown, replacing it becomes necessary. However, this does not resolve the issue alone. If the new fuse fails and blows again, it points to a short circuit in the A29 fuse circuit, requiring further repair. Ensuring proper electrical regulation by replacing faulty fuses is key to addressing communication failures in these automotive systems. In troubleshooting step 4, assessing the +B backup line for continuity and voltage is crucial. First, turn the ignition switch to lock, 0, and then disconnect the gauge control module's 32P connector. You'll then proceed to measure the voltage across 2 designated test points. The expectation is to find battery voltage at this test point, ensuring that the +B backup line is functioning as intended. The test involves measuring between the first test point at gauge control module pin number 1 and a body ground as the second test point. If you find the expected battery voltage, you can confidently move on to the next troubleshooting step. If not, it indicates an open circuit or high resistance in the wire, necessitating repairs to restore proper electrical continuity and communication. In step 5, the troubleshooting process focuses on verifying the ground connections. The first step entails checking for continuity between test points connected to the ground line. You'll begin by ensuring the ignition switch is set to lock, 0, and that the gauge control module's connector is again disconnected. The procedure will involve checking continuity at 2 specified test points corresponding to the ground wires. You should confirm that continuity exists between gauge control module pin number 4, black wire, and body ground, as well as between pin number 32, brown wire, and body ground. If continuity is confirmed at both points, you can confidently proceed to step 6. If either continuity check fails, it signifies a problem with the ground wires or poor ground connections at locations G502 or G503, leading to the necessity for repairs to clarify ground connections. Step 6 involves checking continuity in the B-CAN lines, which are crucial for communication. Begin by disconnecting the automatic lighting control unit's 14P connector before you check for continuity between designated test points. The testing focuses on the B-CAN H line, which must be inspected. Using the appropriate testing tools, one needs to check continuity between the B-CAN H pin at the automatic lighting control unit and the corresponding pin at the gauge control module. If continuity is confirmed, it suggests that the issue lies within the B-CAN L wire, potentially signaling poor connections or opens that need fixing. However, if no continuity is found, it points to a problem with the B-CAN H wire itself. Understanding these connections is imperative for ensuring effective communication within the vehicle's integrated electronic systems. In troubleshooting Step 7, continue the examination of the beacon lines for continuity by performing similar checks as in Step 6. Once again, disconnect both the gauge control module 32P connector and the automatic lighting control unit's 14P connector. Measure the continuity between test points linked to the beacon H lines. This step is critical for understanding whether communication exists between the automatic lighting control unit and the gauge control module. If continuity is confirmed, it indicates that the beacon L wire is the source of the problem, suggesting issues like opens, shorts, or corrosion. If continuity is not established, that could point toward problems specifically within the beacon H wire between the two components. This further informs your diagnostics and can direct you to repair or replace the afflicted wiring to restore effective communication. After completing all necessary repairs, final verification is critical in ensuring the effectiveness of those repairs. Start by reconnecting the connectors and ensuring that all connections are secure and free of corrosion. Following this, use the HDS to perform a final check for any remaining DTCs, particularly looking for the U128D code. It should be absent if repairs were successful. Also, performing a test drive is advisable to confirm that both the gauge control module and the automatic lighting control unit are functioning correctly during operation. This step verifies that the systems are no longer throwing codes and that the driver receives accurate information. Proper verification is essential to ensure ongoing reliability and usability of the vehicle systems affected by DTC U128D. Preventive maintenance is key to avoiding issues like DTC U128D in the future. Regularly checking the connections throughout the vehicle's electronic systems can help prevent loose or corroded connections from causing communication faults. Conduct inspections of wiring to identify any signs of wear or damage that could lead to shorts or opens, particularly in areas prone to movement or abrasion. Maintaining battery health is equally important, as a weak or failing battery can produce unreliable voltage levels that impact communications between the automatic lighting control unit and the gauge control module. Furthermore, keeping your vehicle clean and free from environmental factors that could cause electrical corrosion or wear is essential. Implementing these preventive measures can significantly reduce the risk of encountering similar issues down the line. In conclusion, DTC U128D represents a critical issue of lost communication between the automatic lighting control unit and the gauge control module in the Honda Civic models 2011 to 2015. This issue can lead to misleading gauge readings, increased driver uncertainty, and potential safety concerns. The troubleshooting process involves a systematic examination of connections, fuses, and wiring to determine the source of the problem. By following the outlined diagnostic steps, technicians can ensure a comprehensive approach to identify and rectify the underlying issues effectively. Incorporating regular preventive maintenance can also mitigate future risks associated with this DTC. Ultimately, a clear understanding and attention to detail in diagnosing DTC U128D can ensure the reliable performance of vehicle systems. Please like and subscribe to the channel. See you next time!